Hello everyone, I hope you all are doing great. We heartily welcome you all to our YouTube channel cadcaemaster. If you enjoy what you see, hit the subscribe button and turn on the notifications so you never miss an upload. Okay, in this session I'll be taking you through the basics of static structural analysis, where you could see I have considered two models. One is a simple plate with hole, and one with the circular plate, where I try to utilize RBE2 and RBE3 for the load applications, and we just compared how we can utilize them and try to run simple structural analysis. We used OptiStruct solver for this, and to post-process results we have utilized HyperView tool from HyperMesh. Yeah, so we'll try to get into these all things, and yeah, so let's get into this. Okay, let us quickly build a model. I'm using SolidWorks for this, so I'll quickly fast forward this video so that you might even know how to create the CAD models using different CAD tools. So instead of doing it in ANSA, it might take some time, so better if you're familiar with CAD tools, just use them and just quickly build the models and just export them. Yeah, so here I'm just applying the curvature radius up to 20. I'm just exporting that model as an IGS from SolidWorks. Okay, so now this is the model. First thing is I need to set up the resolution. So I'll go to presentation parameters and set the default to 2, and I'll just heal the model. Okay, so this is the first step. So once you do this, so better orient all the gray outside. So some regions are yellow outside within, so we try to just modify that. Now I'll just mesh this model with the ortho tria. Target length I'll keep 5. So now I should see the mesh. This might be a software glitch. I'll just switch to surface again, surface mesh. You could see it's visible. So as I've just customized my general tab, so that might be a glitch. Okay, so now once you have this model, start building the SPC boundary conditions and loads. Now you could see we have all the things. If you just select new, you have the contact sets, material, property. Okay, then we have the boundary conditions. So I would like to define the SPC. Okay, just select the drop down and use the nodes, and then the full area 1 2 3 4 5 6, everything is fixed. Now you could see all the SPCs are assigned, and this is the visual representation. Now I would like to release the mesh. So before that I'll apply the RB2. Let's do that. Okay, why I'm applying the RB2 is, instead of defining the boundary condition on that particular grid point, so better take one common node on that to apply. Okay, you could see there are yellow grids. This is shared with multiple shape points, so there are CAD as well as FE, right? So I need to delete CAD. So this is the one, right? So I'll turn off this RB2 as of now and the SPCs, and then I'll just delete this complete CAD which I have just imported into ANSA. Okay, now you could see we have the SPC and RB2, correct? Now it's a single center node which has been referenced to all the grids which are there at the circular section. So now I need to define the load on that. Now you could see this, I think, taking all the nodes. I need to only select the center grid. Let me see. So I'll just define first. Okay, it is taking all the grids. I think I'll change later. Unit load, and here along I think it should be Y, so I'll take it as minus 50,000. Newton. Yeah, you could see. You just activate this one, check the force. You could see now it shows me on all the grids it has been applied. So better I'll remove everything. So what I can do is I'll just remove this grids. Better first I'll delete. Okay, first let me assign the grid. Just move here, hold the shift and question mark, just select that, middle click. 541 is the grid ID. Yeah, it's been applied. Now remaining everything I would like to delete. So what you can do is, you could see in the force we have 49 forces, so it should ideally have only one, so except one. So uncheck the first one and delete everything. Yeah, now this looks fine. Everything is fine, no issues. Yeah, so once you define everything, next step is to define the deck. So for that I'll just go to this one, so linear static. So for the linear static, what are all the global outputs and the header needed, I'll just take it automatically here. Just click OK. You could see header has been automatically assigned. So now you can just manually modify this. So what I'll do is I'll just remove this SPC and loads, and I'll define the subcases. You can even define globally, but right now I'd like to have the subcases. So you can write subcase 1 here. In the subcase 1 I would like to call, very important, so if you want to run the structural analysis, SPC1 and load 1. Okay, whatever the SID we have defined, I'll just call it here. If you want to call it from the bottom also, you can just shift question mark and you can call it, but no issues. Yeah, very important thing is the shell model. I'll just use the detect tool from the volume mesh, and this is the one, the volume detected. I'll just switch to DetFM and I'll define a growth rate to 1, and I'll simply right click and mesh so that I can create the solid mesh out of it. Now we have the complete solid volume with solid mesh. Okay, so now you could see we have the property assigned. Material is there. Two different material, better assign single material for the shell as well as solid properties. Okay. Now very important thing is you need to define the material, or else you'll get the error. Again, you might need to come back and define the material, and again you need to output. So better you define every time. Yeah. So thickness I'll assign it here 0.01 because shell I'm not going to consider at all. Okay, it should be treated as a membrane only, just for reference. So we are running the solid volume analysis on this one, solid model in short. Yeah, you can even delete the shell completely, there's no issues, but if you keep it as membrane, the impact is very minute, that is least. Okay, so now in short we just took the CAD and meshed it, defined RBE2, or on RBE2 we applied one force and SPC has been applied and deck has been prepared. I'll just output this with respect to visible all. Okay, output all, and then thickness, and just click OK. Output is done. So now you just import the model here, basic static analysis. Just click open, import, and here you need to go to file, import solver deck, then you can get this one. So here just click on analysis of extract, just run this. So if you have the good system with I think 128 GB RAM and good graphics and everything, so it will easily run. Okay, just click on the result, so it will take you to the hyperview from hypermesh. Okay, now I would like to see this elemental stress. This is how it looks like. You could see it as 2455 megapascal is the stress distribution. Whatever the load had applied, it might be too much, in the sense 50,000 Newton on average 500 kgs on this model is too much. So it should be around 245 to 300 megapascal. Then it will be under elastic limit, or it will be under operating condition. The displacement you could see is 7.4. Displacement is also too much, in the sense definitely this component is going to fail. Just for Just for your reference, I just tried to set up the deck and try to run a simple test model with RBE2. Yeah. So now, very important thing. So why can't we use RBE2 instead of RBE3s or RBE3s instead of RBE2? That we need to cross verify. So what I'll do is now go back here. I'll define RBE3. So we need to know the difference also, right? So I think I have created the previous video, and there's one video which explains the same, where what should be the difference between RBE2 and RBE3 where we need to use. So basic example I have covered, but with this particular analysis where I'm covering the structural analysis, so here also you'll get to know what exactly the difference and how we need to use the RBE2 and RBE3s. Yeah. Now we just ran the analysis with RBE2. I'll just remove the RBE2. So we have the RBE3. Now, very important thing is this RBE3 grid is not connected to this load point which we have defined, right? So what you can do is you can use the paste option and paste RBE3 grid with the force load grid. Okay, the grid ID you can check. So for that you just need to activate the grids and then just go to info and just select everything. It shows grid. It's not showing. You can just go to force panel. Okay, now I think it shows 581 grid. Yeah. If we double click on the grid and it shows 581. So just to cross verify, just go to force, that is load which you have applied, then from there you can just find out which exactly the grid you have chosen there, right? So and this RBE3 is free, as I told. I just need to paste that RBE3 grid 2233 on the 541. Just use the paste, select that, do this, middle click, done. Okay. Now RBE3 is connected to our particular load case which we have defined. So if you want to check that, just go to double click on this one. You could see here it is 541 grid ID GI here. And now if you go to force and then if you check there, it is 541. Yeah, on SPD. Well, so once you're done with this, just output this one here. And now we'll see how exactly RBE2 and RBE3 will help us to get the results and which should we consider. Well, so here everything remains the same, no need to change anything, just we replaced RBE2 with RBE3, that's all. So just you can rename it. Everything is fine. I'll just delete one subcase which I additionally added, no need here. So just save it. Now go to HyperMesh, just load it once, open the new session, very important. Just import, click on analysis of struct, replace the model and just run it. Now don't open the result here, just quickly go to the previously opened hyperview, just open this new panel here, just click on open and then just select RBE3 H3D file, this one. This is 𝐵𝐻, so this icon shows the H3D. Now you can just synchronize or just directly copy the whatever the plot you have, just select all selected. So you could see we have the same stress plot. Here there is no difference at all, right? It almost remained the same, but you could clearly see the stress distribution at the whole region which we have it with load applied. There are slight deviations with respect to the fringe, right? So the fringe plots are slightly different at the whole region compared to RBE2 for the RBE3. Okay, so this is the small deviation. But with respect to this application, means whatever the boundary conditions and the species which we have defined, I don't see a significant effect on the stress in short. But when it comes to stress distribution, it is changed. Okay, so you can even see the displacement. I see it is 7.453. If I see here, for the smaller it is 7.5. In short, with respect to leg length, RBE3 is trying to apply the or distribute the load. So here it is quite difficult to find out what is happening, right? What exactly we can do here is, means in this particular whatever the model we have considered, example model, we had seen how we can set up the deck. And with that, we try to run the basic structural analysis by using the simple boundary conditions, that is RBE3, RBE2, SPCs, and the basic load application. Okay, you can even also see clearly if you consider the RBE3, it will try to distribute the force or the load whatever you have applied with respect to leg length, wherein here it tries to equally distribute the force from the center point. It will refer that as a reference and it will try to apply the load, distribute equally for all the neighboring grids. Now to analyze this, I would like to work on this model, a simple circular plate. I'll just remesh it, means generate the mesh first. I think mesh is too fine. What I can do here is just improve it again. Instead of Control Z, just go average to 5. Select everything, middle click. Yeah, this looks fine. So now I could still see there's a CAD. So I'll just go to release mesh. So I can hide the FE and delete the CAD. Done. So again open the FE. I'll just hide the grids. This is how it looks like. Next thing, I'll just define the SPC and RBE2 for this model. Select the closed loop. On the closed edge, I would like to take it 1, 2, 3, 4, 5, 6. All the 6 degrees of freedom should be constrained. Should we have fixed it? Yeah, kind of welded or whatever it is. Now I would like to apply RBE2 at the macro region. So here, if you switch to macro, only that perimeter, circular perimeter region will be selected and RB2 is defined for that surface. Now, on that RBE2 grid point, I would like to apply the loads. So it is exactly here. Just go to force, just select this grid point. So again means it is giving me again select all the nodes. So just switch to single grid. Can define the boundary condition. So load should be acting towards C direction. In this case, you could see the trio. So positive 50,000 Newton. It is on grid 2. Yeah, this is done. Next thing is you can just simply set up the attack. And so I have applied the material. Its material is already there. We define the boundary conditions like SPC and force with RBE2. Now again we'll switch to structural. Just create the default header, linear static. Can just create a subcase. can just copy paste SPC1 and load one, or else you can just retype it. It is completely on you. Yeah. Can even shift question mark here so that it will directly take you to the main table from where you can just do the selection. So let's say here, Control Shift question mark, then just select the, yeah, it's done. So now just output this one as an obstruct file. So it should be on circular plate. I'll just define the same. Save. Now run this analysis. In short, it's simple SPC and the load case. We tried to run it. So I'm just importing the model here. Okay. It shows material is not defined. I told you, right? So very important. So go back. Just double click on the material. So it is not defined. Again, you can just output the same. Extract. Replace this one. Done. So go back to Hypermesh. Go to Nav session. Import the file. SolidDeck. Yeah. Click on it. This one. So import the file. OptiStruct. Analysis. Yeah, it's done. Again, you don't need to open the hyperview here because anyway we have one hyperview. I'll just switch to 4 panels. So here I'd like to load the model RB2 with circular plate. Now here you could see there's no float assigned for this, so just double click on the float. Displacement is being applied. So you could see red region, everything is with exactly 41, and orange is somewhat to 36. Stress is too much here. I think it should be, yeah, too much stress. In short, what are the 50,000 Newton which you have applied along? Why it is too much for this model? But I hope you got to know how we can just play around the settings. So next thing, I'll simply remove this RBE2 and apply with RBE3, and let's see how it is varying. Just switch to again MAC ID, just select this region, next. Yeah, so it is done. So we have RBE2 plus RBE3. We now carefully need to delete RBE2, and on that grid point where the load is applied, that we need to connect with this particular RBE3. Yeah, so the grid point is 2, and if I go to RBE3 and check, okay, so I just deleted the RB2. Now here it shows grid point 3, so I need to change it to grid point 2. So how do we do it? So the best option is you can use the base tool. It is quite difficult to understand it, right? So where exactly it is lying, so how we need to just drag or push it, but in ANSA it is very easy. Let's see. So this is the grid point, exactly at the, on average it is center. Now I have zoomed it in, so I'll just select this one and this one. Middle click. Yeah, that's almost, it seems it is done. Even check it by just double clicking on the RB3. the grid ID is 2. Well and good. So now model is intact. So we can easily work on this model, defining the remaining boundary conditions. A very important thing is we just ran it with the RBE E3s, E2s. Now I need to just run it with RBE3. So we just changed it. So I'll just rename it as RBE3 all output. Let's just bring it back to hyper mesh. Now just select the new session. You can just remove this one, no need. Just select the last one, RB3 pleat, circular pleat. Now analysis tab is active, switch to OptiStruct, go to OptiStruct again. So again it will ask you for the replace the file and run. Yeah, it's clear. Now I just need to load that file here. Let's see how it is going to impact with respect to RBE2 and RBE3. Yeah, I could see there's a drastic change with respect to the load application. So I hope you got it. So where exactly we need to define the RBE3, we need to understand, think practically as per the manufacturing need. We need to select RBE2 and RBE3 very politely and with respect to precision. So we need to do it. Yeah. So here it is clear that the leg length, where it is exactly too less, that region it is too much moving, in the sense there's a lot of force applications on that region. Where the leg length is too high, for there, due to the high leg length, the load distribution is slightly or less than the center leg length, in short. Yeah, I think from this you could able to understand how we can do the basic structural analysis and the comparison between RB2 and RB3 basics, and it should be clear for you guys. Yeah.
We heartily thank you all for watching this video. If you enjoyed this video, don't forget to hit the subscribe button and give it a thumbs up. Follow us on Facebook, LinkedIn and Instagram for behind the scenes content and the updates. Stay curious, stay awesome, and see you again in the next video.